So as I said, we have 157 students here. And I just take a look at the numbers. Around 70 students, they're from data science and analytics. And the rest of them, they are from artificial intelligence and data computing. So this is third time I have been teaching this course. The first time we have around 80 students. And last year we have around 100 students. And this year we have 157 students. So this is a very huge one. Okay, so if you could not clearly hear what I'm saying, interrupt me. And if you could not see clearly the screen, interrupt me, okay? Make sure you can understand every piece of information I'm talking in here. Oh, I see one of my students. Okay. So, okay, since this is AI concepts, the first question I throw up to you, where do you see AI in your daily life today? What's that?
I'm just saying like that.
Something.
Yeah, like if you just mention AI, I was like, maybe it's just about the plagiarism or something like that.
Thing, of course, this one thing, because AI basically is the dual nature is a dual technology, right? So they probably can have positive and can have negative. Of course, plagiarism, that's the negative one. Anything else? Anything else? Don't be shy. Don't be shy. Anything else? Nothing? Hey, Siri, is that an AI? How many of you using iPhone? Siri, right? And what about recommendation system? Anyone use Netflix? YouTube? You can see this online website keep recommending you something that you probably prefer to see, right? TikTok, exactly. Anything else? Since this is about recommendation system. And also AI for healthcare, for medicine, AI for science, material science. So these are a bunch of different AIs that we can see in their life, right? Huh? What's that?
Image imprinting.
Yes, exactly. Image imprinting. That's right. Lots of things. Okay, be active. Otherwise, you feel sleep. I feel sleep as well. So this way we can, more interaction. Keep you feel like, okay, this is so boring. I just want to sleep. That is at night. This is the night lecture. Okay? This is one way, not keep you like feel you're going to sleep. All right? And so this is our agenda for this semester to be determined. And the first day, we are going to introduce a little bit what is AI, what's the basic ideas of AI. And we're going to further different things, search, optimization, knowledge representation. How many of you have been took AI-related course in your undergraduate? Raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Only just a few? And how many of you are familiar with these terms? All. Or at least 50%. The terms. 1, okay? You are an expert in this course. This is normal. This is normal. Of course, there are some overlap. Even in you are taking courses in PolyU, you will see they probably will cover something that with overlap. Okay, but we have different focus. We are focused on concepts, ideas. Okay, and later on I will show you the history of AI, and you will see, you will understand why this syllabus contains these components. Okay, and from time to time, I will also invite some guests to share us more advanced AI to us. Okay? Okay, from time to time. So this is our learning objective. Masters basic searching techniques for problem solving. Of course, we are using AI to solve problems. Even your assignments, right? Ask ChatGPT to help you. Can we use ChatGPT in this course? Of course you can. For your assignment, but your final, of course, no. Okay? Okay? I basically encourage you to use ChatGPT. They can be a very good assistant to help you. But that is just an assistant. You know, garbage in, garbage out, right? If you could not give very good prompt, then you could not get very good results. If you don't understand the thing, you could not identify which results more fit your solution, right? And know how to represent knowledge and use it in inferences and reasoning. We're doing reasoning, we're doing inferences. How do we do that? And design, develop knowledge-based expert system. So what is expert system? There's a term, expert. What does that mean? Use basic machine learning techniques to solve different data analytic problems. So how many of you have been taken any subject related to machine learning? Just machine learning. If you search online, there are a bunch of different courses just called machine learning, right? But what's the relation between AI and the machine learning? Are they pointing to the same thing or different things? What's the relationship? What's the difference? And understand artificial neural networks and deep learning. Okay, what is deep learning? It is related to machine learning, artificial intelligence. What are differences? What are correlations? Any ideas? So these are our basic learning objectives. And we have some prerequisites, okay? Better if you have the following background. Programming, of course, we have some programming assignments. And the calculus, probability and statistics, linear algebra, algorithms. So there are more general ones because this course, we cover so many different things. They are just more on the surface, more about the concepts, the ideas. We will not go to too many details, okay? And okay, let's go to our grade assignment. So in this semester, we have two components. One is the assignments. And then we occupy 30% of your total score and the final exam. And for the assignments, do not be late. Every year, always a few students send me email. Sorry, Professor Lin, because something, I have to be late. Every semester. What can I do? So please do not be late. We have the policy, the late policy, okay? If you're being late, 1 day late, 20% reduction. 2 days late, 40% reduction. And 2 days more than 2 days, your score B will just gone, okay? And so for more details about the assignments, we will send the documents, more description details, and we will put in the Blackboard, okay, on due course. So we have the report. This is our tentative submission deadline, October 27. Usually you will have 4 weeks to finish your assignment, okay? Each assignment, you have 4 weeks, okay? And for the final exam, so they are all writing problems. And you will be aware of what we cover in your tutorial time. This is something that you can use to prepare your final exam, okay? And it is open book, but a closed internet. So you could not use ChatGPT, okay? Okay, so utilize the ChatGPT when you study this course, but be prepared, be well prepared for your final exam. Even that is open book. You know, what does open book mean? Usually you barely can find something from what to bring in. You probably can bring some concepts, some ideas. Okay? And since we have 157 students, if you have any questions, like about assignments, about your exams, about the tutorials, you can send questions through the Blackboard. We'll create a communication channel. You can just ask, like, for example, about the confusion about the questions, if you have something that confuses you. And because how can we be responsible for tutorial? If you have any question, you also can come to him on Monday. And how we will focus on the assignments. If you have any scores, you can also come to him about the assignments, okay? And academic integrity, even though you can use ChatGPT, but do not just copy and paste. This is not good to you. And I know it's quite expensive for a master program. I think the fees kind of keep increasing every year. Is that right? It's quite expensive. So this is not deserved to, to do this plagiarism. This is a negative use of AI, all right? And also you can discuss with your classmates. How many of you, at least no more than 5 students in this room? Or you are all fresh? All fresh? No? How about 1 to 2 minutes to know people around you? This is a very good opportunity. You can now make more friends in your same majors or different majors. Okay, just finish this subject and you know nobody in here. That is not good. All right? Okay? So all materials related to this course will be posted on the Blackboard. You can see I post the slides last night, but still I make some changes because every semester I will change my slides a little bit because there's some information I need to update. The news, the AI has changed so fast. So every year, even though I teach the same course, I will keep updating the information there. I will also upload this new version after today's lecture. Okay? Okay? And do not distribute to public. That's the copyright thing. All right? So this is the answer. Yes, you can use it for your assignments, for better understand AI concepts, for better understand how to use AI. Okay? And we do not have official textbook, but we will provide lecture notes and tutorials. And here are list some reference books. But frankly speaking, I don't think any of you will find a book and to read. Any of you would? Raise your hand. 1, 2, just a few. But it's very good that you can come to a book and to read. Because most of people right now, they are just rely on ChatGPT. Whatever any concepts you are confusion, just go to ChatGPT, ask what is something, and then come up a few sentences to describe the ideas. Is that the common used way right now? Is that yes or no? Yes, that's the thing. Even my students, they're doing the same thing. But still, you will need to have a skill to identify if the answer is correct. Because there's a hallucination in there. Garbage in, garbage out. Okay? So, why taking this course? Is this a mandatory course? Or is it an optional one? Just curious. For your side, is that a mandatory course or optional? Huh? Option. Option. Okay, option. So then why are you taking this course? Why I'm taking this course? Why?
Uh, because it's related to uh,
Don't be shy. It's okay. And it's okay. Okay, first of all, I think some of you keep silent because you think your English is not good. I guess this is one reason. Because usually sometimes my students keep silent during the lecture time and come to talk to me in Chinese in break time. In fact, you are not so shy, but because you think your English is not good, but you know this is the luxury time that you can practice your public speech. Luxury time that you can practice your English in public. See? So what's the reason?
oh, okay, because my main major in my university is computer science and technology. So maybe when I choose my courses in PolyU, I want to choose some courses about computer or maybe this kind of courses. So I choose uh, AI.
Okay. Okay. So any reasons? Okay.
I think I choose this course is because this is a concept lesson. So when I'm really interested in AI, and so I study this master. I think the first semester I will study some concept of AI first, and I can study a harder or more difficult course in the next semester or even next year.
See, you can take this as an introduction of AI. That's correct. You can have a high level picture of what is AI through this semester. And then you can see what is you're interested in. You can go further. Any one more opportunity? Any other reason? One more?
My reason is same like the student before. I also think this is a maybe is a basics lecture that it can make me better to prepare in the further study, and I think it can make me know more about artificial intelligence and how to use better.
So in fact, I'm quite surprised. Nobody tell me because probably I can learn some AI. Then I can find a job related to AI. You are more focused on further study. We are so many good students in here. They are focused on study. This surprised me because I expect some of you saying, okay, probably I can find a job after graduate because I know AI. I can find some related jobs. Okay, let me show you some stats. No, in here. Some breakthrough news about AI. First, I think I just pick one to show you, okay? One is about DeepSeek, the other is the NVIDIA. Which one you pick? Because of time, we just show one. The one from NVIDIA, the one from DeepSeek. NVIDIA, okay. In fact, if I were, I would pick NVIDIA because then more information about that. AI. Hmm. So in fact, this is a brief one. The original one is something that around 2 hours. So I just put a brief one that you can see what happened in this event, NVIDIA's GTC event, okay?
What an amazing year. At NVIDIA. So through the magic of artificial intelligence, we're going to bring you to NVIDIA's headquarters. I think I'm bringing you to NVIDIA's headquarters. What do you think? This is where we work. This is where we work. What an amazing year it was. And we have a lot of incredible things to talk about. And I just want you to know that I'm up here without a net. There are no scripts, there's no teleprompter, and I've got a lot of things to cover. So let's get started. GTC started with GeForce. It all started with GeForce. And today, I have here a GeForce 5090. And 5090, unbelievable, 25 years later, years after we started working on GeForce is sold out all over the world. This is the 5090, the Blackwell generation, and comparing it to the 4090, look how it's 30% smaller in volume. It's 30% better at dissipating energy and incredible performance. Hard to even compare. And the reason for that is because of artificial intelligence. GeForce CUDA to the world. CUDA enabled AI, and AI has now come back to revolutionize computer graphics. What you're looking at is real-time computer graphics, 100% path traced. For every pixel that's rendered, artificial intelligence predicts the other 15. Think about this for a second. For every pixel that we mathematically rendered, artificial intelligence inferred the other 15. And it has to do so with so much precision that the image looks right, and it's temporally accurate, meaning that from frame to frame to frame, going forward or backwards because it's computer graphics, it has to stay temporally stable. Incredible. Today, I'm super excited to announce that GM has selected NVIDIA to partner with them to build their future self-driving car fleet. The time for autonomous vehicles has arrived, and we're looking forward to building with GM AI in all three areas. AI for manufacturing, so they can revolutionize the way they manufacture. AI for enterprise, so they can revolutionize the way they work, design cars and simulate cars, and then also AI for in the car. So AI infrastructure for GM, partnering with GM and building with GM their AI. So I'm super excited about that. One of the areas that I'm deeply proud of, and it rarely gets any attention, is safety, automotive safety. It's called HALOS. In our company, it's called HALOS. Safety requires technology from silicon to systems, the system software, the algorithms, the methodologies, everything from diversity to ensuring diversity, monitoring and transparency, explainability. All of these different philosophies have to be deeply ingrained into every single part of how you develop the system and the software. We're the first company in the world, I believe, to have every line of code safety assessed. 7 million lines of code safety assessed. Our chip, our system software, and our algorithms are safety assessed by third parties that crawl through every line of code to ensure that it is designed to ensure diversity, transparency, and explainability. All right, let's talk about data centers. That's not bad, huh? Blackwell is in full production, and this is what it looks like. It's an incredible, incredible, for people, for us, this is a sight of beauty. Would you agree? This is. How is this not beautiful? How is this not beautiful? Well, this is a big deal because we made a fundamental transition in computer architecture. And so the thing that we had to do was scale up first. Well, this is the way we scaled up. I'm not going to lift this. This is 70 pounds. This is the last generation system architecture is called HGX. This revolutionized computing as we know it. This revolutionized artificial intelligence. This is 8 GPUs. Each one of them is kind of like this. Okay, this is 2 GPUs, 2 Blackwell GPUs in one Blackwell package. 2 Blackwell GPUs in one Blackwell package. And there are 8 of these underneath this. Okay, and this connects into what we call NVLink 8. This then connects to a CPU shelf like that. So there's dual CPUs, and that sits on top. And we connect it over PCI Express, and then many of these get connected with InfiniBand, which turns into what is an AI supercomputer. This is the way it was in the past. We need to disaggregate the NVLink system and take it out. So this is the NVLink system. Okay, this is an NVLink switch. This is the highest performance switch the world's ever made. And this makes it possible for every GPU to talk to every GPU at exactly the same time at full bandwidth. Okay, so this is the NVLink switch. We disaggregated it, we took it out, and we put it in the center of the chassis. So there's there are 18 of these switches in 9 different racks, 9 different switch trays, we call them. And then the switches are disaggregated. The compute is now sitting in here. This is equivalent to these 2 things in compute. What's amazing is this is completely liquid cooled. And by liquid cooling it, we can compress all of these compute nodes into one rack. This is a big change of the entire industry. All of you in the audience, I know how many of you are here. I want to thank you for making this fundamental shift from integrated NVLink to disaggregated NVLink, from air cool to liquid cool, from 60,000 components per computer or so to 600,000 components per rack, 120 kilowatts, fully liquid cooled, and as a result, we have a 1 exaflops computer in one rack. Isn't it incredible? The way to solve this problem is to disaggregate it as our partners. So let's go talk about robotics, shall we?
And this is the fancy part.
Well, the time has come. The time has come for robots. Robots have the benefit of being able to interact with the physical world and do things that otherwise digital information cannot. We know very clearly that the world has severe shortage of human laborers, human workers. By the end of this decade, the world is going to be at least 50 million workers short. We'd be more than delighted to pay them each $50,000 to come to work. We're probably going to have to pay robots $50,000 a year to come to work. And so this is going to be a very, very large industry. We created a system called Omniverse. It's our operating system for physical AIs. You've heard me talk about Omniverse for a long time. We added 2 technologies to it. Today I'm going to show you 2 things. One of them is so that we could scale AI with generative capabilities. A generative model that understands the physical world. We call it Cosmos. Using Omniverse to condition Cosmos and using Cosmos to generate an infinite number of environments, allows us to create data that is grounded, controlled by us, and yet be systematically infinite at the same time. Okay, so you see Omniverse, we use candy colors to give you an example of us controlling the robot in the scenario perfectly, and yet Cosmos can create all these virtual environments. The second thing, just as we were talking about earlier, one of the incredible scaling capabilities of language models today is reinforcement learning, verifiable rewards. The question is, what's the verifiable rewards in robotics? And as we know very well, is the laws of physics. Verifiable physics rewards. And so we need an incredible physics engine. Well, most physics engines have been designed for a variety of reasons. They could be designed because we want to use it for large machineries, or maybe we design it for virtual worlds, video games and such. But we need a physics engine that is designed for very fine-grained, rigid and soft bodies, designed for being able to train tactile feedback and fine motor skills and actuator controls. We need it to be GPU accelerated so that these virtual worlds could live in super linear time, super real time, and train these AI models incredibly fast. And we need it to be integrated harmoniously into a framework that is used by roboticists all over the world, Muchoka. And so today we're announcing something really, really special. It is a partnership of 3 companies.
Okay, so there are some keywords. I'm not sure if you heard about that. One is computing architecture. How many of you playing computer games? Is it easy to buy GPUs? It's hard right now, and it's super expensive, right? This computing architecture. Later, we introduce one key driver of AI, why it develops so fast. Computing is one main reason, right? And robotics, can you imagine someday? Every one of us, we just can 躺平, lie flat. And we can hand over all of the work to the robotics to help you. You can see ChatGPT can help you to generate papers. But right now, the quality is not so good. But someday, is it possible that it can generate good papers, even better than the researchers? Is it possible? Are you the positive one or negative one? What do you think? What do you think? Is it possible that the AI is so powerful, can handle everything? Need some food for thought, okay? Everyone have their own perspective. Some are positive, some are negative. So now let's go back to our lecture, okay. Okay, here. And as I mentioned, when asking why you take this course, all of you, the answers they are for further studies. So what about your career? So what are you going to do after graduate? Further PhD study, doing some research, or just find a company? Any idea?
No idea.
Never mind. So any idea? So I'm going to go to the traditional computer science giant company like Meta, OpenAI, and some company in China, Baidu, Tencent. Or you are going to do some interdisciplinary research. Now in my group, we are doing some interdisciplinary research. We are not doing core computer science. We're using AI to facilitate the development of other areas. And I will show you some statistics of that published by Stanford related to AI. So this is some information I just updated. So this is different from the one I uploaded yesterday, because this is published in 2025 by Stanford. That is Artificial Intelligence Index Report. From job-wise, you can see through 2022, 2023, 2024, more and more jobs that are related to AI. We are not saying these jobs are hiring in giant company, IT company. In many different companies, they need AI peoples. In academia, you can see every single year we have so many papers published. In 2023, around 242,000. Every day, if you take a look at archive, if you have a little bit of research experience, you will know every single day, many papers, even in just the one topic published in archive, they might not be peer-reviewed in this area about AI. This is this is trendy things. All people talking about AI. Even like I joined a workshop from Department of Applied Physics. And that is physics. They're also talking about AI for physics. Everybody, not only people from computer science, not only people from artificial intelligence and data science. Every people, they're talking about AI. And here are some takeaway message from this index box. I will just briefly introduce what are the trendy things globally, okay, based on this index report from Stanford. AI performance on demanding benchmarks continues to improve, keep improving, even though something that performs not so good. AI is increasingly embedded in everyday life, from healthcare to to transportation. For example, the Baidu's affordable Apollo Go robot taxi fleet now. And the business is all in on AI. Private investment. In fact, I also have been teaching one course in business school. That course is called Big Data and Artificial Intelligence. The students, they are all, you can think that's kind of an MBA course. MBA, sort of MBA, Doctor of FinTech. This is another doctor degree. The students, they are all from the banker, the manager, the CEO of a company. And they are seeking more investment opportunity in AI. Every year, I've been like, the course is a very small class, usually around 20 students there. And they are, you can think of most of them, they are older than me. They are expertise in their areas, but right now they are seeking the investment opportunity on AI. Okay, this is one more piece of information. And the US still leads in producing top AI models, but China is closing the performance gap. So what do you think about DeepSeek? Have you compared different models, DeepSeek, ChatGPT, and other models? Which one is better? Cloud. So you think that is better? Any ideas? Anyone believe DeepSeek is the number one? You can keep an answer in your mind, all right? So still right now, we all think US is the leading, but China has been doing well, trying to close the performance gap. And the global AI optimism is rising, like 83% in China, 80% in Indonesia. Their strong majority see AI products and service as more beneficial than harmful. They think AI bring more beneficials to human than the harmful ones. Okay? And AI becomes more efficient, affordable, and accessible. Of course, it can just simply download DeepSeek, the basic model. It can fine-tune with your own data and create your own model. You've heard about pre-training fine-tuning. You can make your own model as long as you have the base model. Okay? So it is more accessible. And there's large models still. We can have small models. We can use multiple small models working together to complete a task that can complete by large model. This is one thing. More efficient, more affordable, and accessible. Governments are stepping up on AI with regulation in investment. Why do we need regulation? Safety issues, ethical issues. This is something I will cover later, okay? The ethical use of AI. That's why government needs to step into AI and set regulations to regulate the use of AI. Industry is racing ahead in AI, but the frontier is tiny. This is something the academia, we are so difficult right now. You can see the technology, they are leading by this giant company, Meta, right? Microsoft, DeepMind. They are doing research far behind us. They publish great papers than us. We academia people, we have so many bottlenecks, especially computing power. Right? So right now, industry is racing ahead than us. If you take a look at the good papers and not mention the products, right? AI earns top honors for its impact on science. Have you aware of the Nobel Prizes? AI for physics, AI for chemistry, and the other one, Turing Award, contribute to reinforcement learning. If you remember one term that mentioned by Jason Huang, reinforcement learning, one major technology in these days. So see, AI contribute to science, physics, chemistry, bioinformatics, so on and so forth. Complex reasoning remains a challenge. So do you think AI right now is so smart, can do everything? Of course not. Last bunch of researchers, they're still working on how to improve the reasoning performance of the large language models. This is a very, very hot topic. AI and computer science education are expanding. See the size of our lecture room. From around 80 students to 100 students to right now, 157 students in my lecture. Not mention any other places, right? You can see the education is spending on AI. Like you see PolyU, the Department of Data Science and Artificial Intelligence is established last year. And any other Hong Kong university as well, they established this kind of AI institution or AI departments. So this is the takeaway messages from this AI index report. These are global trendy informations. All right? So let's go back to the AI concepts. What are going to cover, except this information provided online, provided globally, what we're going to cover. What is AI? Again, everybody talking about AI. From computer science, from data science, from physics, from healthcare. So what's in your mind? What is AI? Everybody talking about it. So what is AI? Be more specifically. You only know what it is. Then you can design or you can use it. So what is AI? Have you think about ChatGPT? Is that just AI? Or anything else? Any idea?
No, not at all.
Artificial intelligence. You can just explain anything you think. So the first way, okay.
I think to make the computer think like human.
Think about human.
I think like if you go back to the deep learning is something similar our brain. Yes.
Right?
Yeah.
The brain neurons. You are going to make a machine, make a computer behave with human-like intelligence. That can be one definition. So let's just look at the answer. In fact, last year, I also searched AI in Google. And this year, I also searched, it gave me the different format of answer. More AI answer. So AI in here is the simulation of human-like intelligence in machine. Human-like, like deep learning, based on deep learning. We have neurons connect together and work together to make decisions. So let's one more term, solve problems, perceive their environment, and act to achieve specific goals. And from the classical way of Wikipedia, AI is the ability of machines to perform tasks, still perform tasks that are typically associated with human intelligence. We want AI to behave with human intelligence, such as learning and problem solving, and there are many different applications. So let's take the one from one book, more technical wise. AI is a big field, and it is a breadth of field which encompasses logic, probability, and continuous mathematics, perception, reasoning, learning, and action. Everything from microelectronic devices to robotic planetary explorers. So this is a more technical wise definition. AI basically covers so many different fields. Down to the earth, they are about probabilistics, logic, mathematics, perception, reasoning. And then you can learn. Right? This is from a very high level definition to the technical wise definition. In this book, 2016, the book I just showed you, define the term AI to describe systems that mimic cognitive functions generally associated with human attributes, such as learning. Like a baby, like learn every day, learn, right? Speech and problem solving. So right now we can communicate with AI. We can prompt text to generate something. You can input some text to generate image, videos, or even to generate your assignments, right? And a more detailed and perhaps elaborate characterization was in the book 2019, Kaplan and Helen. The study describes AI in a context of its ability to independently interpret and learn from external data. So in here, we will see one other drives why AI is so powerful. Come to the scene. External data. You can achieve specific outcomes. Why ChatGPT is so powerful? Number one is computation power, and the other one is data. It needs large volume of data and train billions of parameters. So it can memorize or really intelligent to do something. What do you think? It is memorized information or it really intelligent to do something? What do you think? What do you think? An AI model is powerful. Is that because it can memorize the training data? The training data means the one that train the parameters. Throughout the semester, you will understand what does that mean, okay? Why data is so important to make a model is so powerful, okay? So still, come back to the question. Artificial intelligence, deep learning, machine learning. Before we get to the answer, let's go through the history of AI. What brings us to here? What brings to us to this so powerful AI in these days? And a very natural starting point is in 1950, a paper published by Alan Turing. The paper is Computing Machines and Intelligence. In this paper, Turing asked the question, can machine think? That is 75 years ago. People, they get start to ask, can machines think? And it answered with the imitation game. What we call that is Turing test. A Turing test means that it can pass the Turing test if it can convince a human judge it's actually a human through natural language dialogue. That means it could not identify if that is a machine or if that is a human. That is Turing test. So this is starting point of AI. So why this paper is so remarkable? Not because it creates some system, or not because it proposed some algorithm, but because it framed the philosophical definition of intelligence to pin down. So you will have to appreciate how hard it is to frame this kind of intelligence, this kind of definition, and for discussion to date. Okay, so the takeaway of the Turing test is that the separation of the objective specification of what we want to do from model design and how we get here. So this is a theme of throughout this course, okay? And at the end of this paper, also Turing discusses two possible approaches. The first one is solve the abstract problems like playing chess through the route taken by symbolic AI. The second one is where we build a machine and we teach like a child. You can think of we teach using what? Using data. If you think of the model AI, you have the model and you build a model and then you teach it like a teach a child. This is the route taken by neuron and the statistical AI. So given these three components, we are going to introduce the history of AI from these three different routes. Okay, so let's go back to 1956. John Mackesy organized a workshop. John Mackesy is the founder of Standard AI Lab. In 1956, he organized a workshop at Dartmouth College. And at that time, except for John Mackesy, the attenders was all Marvin Minsky, Alan Newell, and Simon. They together make contributions to AI. And in here, they have a very bold proposal, general principles, general AI. They have the very big ambition. Every aspect of the learning or features or intelligence, they can be made. You can think of this very, very big ambitious they think AI can be done. This is a post-war, and the computer just come to on the scene. It's a very exciting time, and people think the AI can do everything. We can have the general intelligence. So in 1952, the Arthur Simon, they have the first program, a checker program. And at that time, it can play at a strong apt level. See, this is in 1952. 70 years ago, this program can play check at a strong apt level. And in 1955, the other two researchers, Alan Newell and Herbert Simon, they designed logical series. And this series can prove theorems in principal mathematical research and heuristical algorithms. And this research, they trying to publish paper on the results. But unfortunately, the paper was rejected. Because the reviewer, probably because of the reviewer, they didn't realize the third author, in fact, is a computer program. And thereafter, they also come up with a general problem solver. They're pushing forward the general intelligence. Still very ambitious and very optimistic. But so you see, like these different researchers at that time, they all think AI, they're so powerful. Machines will be capable within 20 years of doing any work a man can do. Is this goal accomplished right now or no? Not yet. But see, 75 years ago, researchers, they are so optimistic. Within 10 years, the problem of AI will be substantially solved. Of course, it is powerful, but still you see so many problems there. AI, large language model hallucination. And Leclerc Shannon claimed that I visualize a time when we will be to robots what dogs are to humans. Really? Even right now, robots, they are not so intelligent at all. Most of them, they are still based on rules, right? I'm rooting for the machines. You can see 70 years ago, researchers, they are so optimistic. But the results, of course, even right now, we have so many obstacles, so many barriers to put AI into practice. Let's take a look, one example, machine translation. The original sentence is, the spirit is willing, but the flesh is weak. Then this machine translation translates this sentence English into Russian. And then a machine translate back to English. This is an amusing story. It goes back to the vodka is good, but the meat is rotten. This is amusing, but failed case, failed AI, right? So because this is an amusing story to us to hear about, but this is not an amusing story to government. So in 1966, LPAC report cut of government funding for machine translation. This marked the beginning of the first AI winter. So you see, even our academia, we need funding to push forward the development of AI. Industry, why they are so powerful? They're leading the AI because they have the money, they have resources. They can buy so many computing resources. They can hire the mature experts to develop their AI models. If you don't have funding, you could not do anything. So in 1966, the government funding just cut off. Okay? So what's the problem? Why failed? That is 70, 60 years ago. At that time, of course, we don't have the computation resource like these days. We don't have a GPU. Computation, of course, this is #1 problem, right? This logical reasoning, usually you involve large volume of such space, and the hardware is limited. That is 60 years ago. We don't have a CPU, GPU, right? And limited information. These logical rules This world is so complex. We have so many different words, objects, concepts in the world. If we want to make an AI model to work, we need to embed these concepts, these objects into an AI model. But we could not do that. Even though you have the infinite computation, you could not have the enough information into AI model. Right? So here comes the 70s to 80s. Here's the experts. So what does that mean? Comes the popular of the knowledge-based system. So right now, researchers are starting try to make use of their expertise, use their knowledge. So they basically use specific knowledge in the form of rules. Of course, we have the knowledge. We just use this knowledge to constrain the space of possibility. We can reduce the space of search. Okay, so you can find the solution. So in here, instead of focus on this general intelligence, in these days, they are more down to earth. They focus on specific targeted domains, the practical system. For example, the specific for chemistry, for medical diagnosis and business operations. So in these days, we can see there are some successful systems. You have a domain expertise. Then this expertise can use their specific knowledge put into a system. So you can use a limited computation to figure out the solution. For example, danger infer molecular structure from mass spectrometry, and also the system that can use diagnose blood infections. Also can use to recommend antibiotics. Okay, so these are some successful knowledge-based systems during 70s to 80s. So the bright side is that we can use domain knowledge to constrain the search space so we can find out the information without need powerful computation, right? And also in these days, there are first real applications that can impact industry. The research in these days, they are not only just academia, playground. They have the real system at that time. But still, what's the limitations of this knowledge engineering? Like playing check, you can set the rules, right? If you play one step, you can further play the next step. You can enumerate all of the possibility. But what about more complex problem? Can you enumerate all of the possibility? And also, this world is not the ideal world. There are some uncertainty. You could not predict. So that's why there are second AI winter here. Because the knowledge engineering, these deterministic rules, they could not handle the uncertainty. And the rules became too complex to create and maintain. It's very hard to scale up to more complex problems. Okay, so here we just the first root of symbolic AI since 1956 and to the end of 1980s. Right now, let's go back to another time, which is earlier time, 1943, neural AI. In 1943, a neurobiologist, Warren McCulloch and Walter Peace, they come up with the first neural network. And in here, they propose the mathematic foundation, the function that can use to implement the logic functions like and or. So in fact, this is the first artificial neural network. But the problem is in this year, they didn't suggest how to train the model. They just give the mathematical formulation, but we have no idea how to train it. And in 1949, the Donald Herb, they proposed the first learning principle. The intuition is based on the cells they fire together while together. This is the basic idea of the learning principle. But the problem is it is local and unstable, so it fundamentally doesn't work. In 1958, Frank Rosenblatt, they come up with the first algorithm, perception algorithm, that can learn single layer network classifiers. And they create a device that can recognize simple images. And in 1959, Bernard Wieser, they come up with a new device that have the learning principle corresponding to linear regression. And in 1969, which is a very important year, Mary Minsky and Simon Pepper, they published a book, Perception. And in this book, they claim that, they showed that single layer version, single layer network, they could not solve XO. This is the logic function that could not implemented by single layer version of neural network. So this is kill the neural net research. And at that time, the trend go back to the symbolic AI. That's why you can see the time from 1943 to 1969, and in 1970 and 1980, that time, that is the rising of the knowledge-based system, right? And during 1980, they start to link the psychology and cognitive science together. This researcher, they create a first convolutional neural network with multi-layers and pooling. And this model can work for images, and it is trained in a very heuristic way. Till 1986, anybody know Geoff Hinton? Heard about him? Geoff Hinton? No? In fact, this is one professor from University of Toronto. This is a big guy in AI. Yan-Le Kun, Geoff Hinton. No? Check the big guys in AI. This is still a very, very old researcher, and he's a professor at the University of Toronto. And Yan-Le Kun is a professor at the University of New York. They're still alive. These are very, very good researcher, okay? Pioneer research in AI. And in 1986, Donald, Geoff Hinton, and Williams, they published a paper that popularized the backpropagation for training multi-layer networks. These are very, very breakthrough papers, backpropagation. How to train deep neural networks. And they also showed that hidden units could capture interesting representations. Everything basically is a representation. That means in deep networks, you can see very meaningful ones to represent object in the world. And in 1989, Yan-Le Kun, even such his name. He's also a very famous guy, famous researcher. So in 1989, they used CNN to recognize handwritten digits. This is also a very good success stories for neural networks. Okay? So here comes deep learning, 2006. Geoff Hinton again. So in 2000, before mid of 2000, at that time, neural models still very hard to train. So till 2006, Geoff Hinton proposed that deep models can be trained in an unsupervised way. And then you can use just a few of label data to fine tune it to make it work. So if you take a look, the pre-training paradigm is still very popular in these days. Like you can download this published large language model, and then you can fine tuning with a few number of label data to make your own use. This is a pre-training fine-tuning paradigm. Get back to 2006. In 2012, a very landmark CNN called AlexNet. This is a transformation paper, a work that transformed the entire computer vision community. And they have a very, very huge performance gain in object recognition. Okay, and 2016, have you heard about AlphaGo? A very big breakthrough. At that time, I was a PhD at the University of Toronto. And we see the video showing the AlphaGo beat the champion, Lee Sedol, in Go. The basic model is a deep reinforcement learning. At that time, this huge breakthrough of deep learning. So since 2016, deep learning firmly established itself as a dominant paradigm in AI. One interesting thing is before 2015, because I was in Toronto at that time, we have a course subject. Before this deep neural network population, the course is called statistical theory. And after that, they changed the course name, but the same content into machine learning. At the beginning, there are not so many students to select this course. But after the change of the name, there are a cloud of students get into this course because of the name, deep learning. It is popular, it is powerful. But the fundamental idea is just statistic theory. So generative AI, since 2020 to now, how many of you have tried to use generative AI? Any tools you think that is generative AI? Huh? What's that?
I think all of us have used something like that.
Use text to prompt to generate some contents, can generate video, image, and text. So this is since 2020. The ability for AI to generate text, images, and videos in response to text prompts, right? The AI research company OpenAI built a GPT. So if I didn't show you generative pre-trained transformer, how many of you know GPT? It is generative pre-trained transformer. How many of you heard about this term? I hope you, okay, 1, 2, 3, 4, 5. Okay, some of you, 10%? Do we have 10%, at least 15 students in here? No. GPT basically is generative pre-trained transformer. I hope throughout this course, after this semester, you all know GPT. What is GPT? Okay? It has become the architecture foundation for its early language model, GPT-1, GPT-2. So against after this, there are so many different types of GPT comes out from different companies. Like 2020 GPT-3, that is 175 billion parameters. In 2021, that text-to-image model, they can use text to prompt to generate image. And 2022, ChatGPT. OpenAI released the AI chatbot ChatGPT. I think before 2022, not so many people, they heard about GPT. Because of this powerful chatbot, everybody can use it. Not only people from computer science, not only people from data science. All of us can use this chatbot, okay? And 2023, GPT-4, OpenAI released GPT-4. Microsoft integrated GPT into its search engine being, even like Google, you can see, if you search Google, you can see that is a GPT generated content, right? And DeepSeek, this is something I update today. I think this is one breakthrough as well. That's from mainland China, DeepSeek, okay? And this is released in January 2025. And right now, I guess in this April, they are on DeepSeek. Which version? V3 or V3, right? Yeah, the newest version. Okay. So right now, you can see the symbolic AI and neural AI. This symbolic AI basically looks in logic, like chase, go. They are all symbolic AI. Knowledge-based system, they're based on if-then rules. These are based on logics. And then we talk about this neural AI in neuroscience, neural networks, right? There are lots of different neural AI, the history along the way. So they have deep philosophical differences. We have different roots, but you see they have some connections. The goal, originally that is rule-based. You can use rule to solve the goal. But you can see AlphaGo, the fundamental technology is deep reinforcement learning. That is artificial neural networks. Use deep learning for pattern matching, pattern recognition. Okay? Okay. Let's take 10 minutes break and come back to the third part. Okay? I need a few minutes to rest. So far, have you known at least 5 classmates in this room? No? 5? Just 5? Know your classmates at least around you. Okay, so we have talked about to lose the history of AI. Let's go back to 1801. In fact, at that time, we haven't used AI yet. This AI term since 1956. And these basically they are not AI, but they are something that build the foundation of AI. Like in 1801, there comes Gauss and Legendre. They create these squares for linear regression. In fact, in here, they just try to fit the model from data. We haven't taken into the intelligence yet. Linear model itself, these squares for linear model itself, is just fitting the model from data. That's it. We don't have any intelligence, right? And in 1936, Fisher developed linear classification. Till 1956, this is in fact AI involved lots of sequential decision-making problems. So there's a trend line that have fixed the gesture algorithms for finding shortest passes for deterministic settings. In 1957, there's a Bellman researcher who created Markov decision process in the context of control theory. So in this case, they can handle the uncertainty in the world. These developments, they are not AI, but they have built the foundations for AI. Okay, even in this 1990s and 2000s, we don't use AI in like today we're using. At that time, they used machine learning. So this is called machine learning, and they have 2 different paradigms. Judy Paul. Any one of you heard his name, Judy Paul? He wrote a book, The Book of Why. Causal theory. That is one bunch of research on AI. Use causality instead of use statistical theory of AI. There's a book, very popular book, the book of Why. And Judy Paul developed Bayesian networks. These Bayesian networks can provide an elegant framework for reasoning under uncertainty. Remember, what's the limitation of knowledge-based system? The knowledge engineering, they could not handle the uncertainty of the world. But using Bayesian networks, they can handle the reasoning under uncertainty, give the satisfying solution that could not give by knowledge-based system, by symbolic AI. Okay? And in 1995, this is also very popular old machine learning technology, support vector machine. This is originated from statistical theory and optimization. It is easier to tune. That's why it is popular at that time. Even right now, different disciplines, they are not using modern AI. They still use support vector machines to solve their domain problems. This is a very powerful solution because it is easy to tune, to train. Okay? So here we have covered the history of AI from 3 different aspects. Symbolic AI, roots in logic, neural AI, roots in neuroscience, and this is statistical AI as a foundation, mathematical foundation for AI. Hopefully, with this brief history, you'll be more understand why the syllabus covers the components. Okay? Okay? So you can see the AI, basically it is a melting pot that cover different areas, different fields. computer science, of course, algorithms, physics for AI, AI for physics, social science, control theory, optimization, neuroscience, statistics. It involves different areas, different aspects. So you can see, if one researcher tells you he's working in AI, in fact, that is very general one. Nobody will know what he is focused on. Even in AI, we have so many different researchers working on different topics. Like myself, we have 2 topics. One is AI for material science. The other one is collaborative AI. We design multi-agent systems for complex reasoning. Very specific topic in the area of AI. Okay? So here comes a question. Is that an engineering or science? Artificial intelligence. Is that an engineering subject or subject? Do you think?
I think it's both engineering and science.
So in what aspect? Why do you think that is engineering?
Because it may need hardware to, connect with real life, and it also contain a lot of theoretical perspective.
Anything else?
No.
Any other ideas? Is AI an engineering subject or it is science subject? Okay, so from engineering perspective, we can build intelligent system to solve problems in the world. AI for engineering, we can do that. AI for engineering, for AI for manufacturing, right now is also very hot topics in these days, not only in Singapore, in Hong Kong, in mainland China. People are trying to implement intelligence to help manufacturing. We can understand the mechanisms, algorithms, and representations for building intelligent systems. For example, robotics for intelligent manufacturing, right? This is one aspect. The other is that we can understand the nature of intelligence. You only understand more about the science, you can create better models. Understand how to bake the physical rules into an AI system. This is something we are working on right now. This is the thing, AI for science. Well, we are from AI. We are AI people. Physics people, they're also working on AI for science. They apply AI for solving their science problem. But what we want to do is that we know better about science, know better about material science. We can create better models that can apply to material science. That is one of our research focus in our group. We want to know more these physical rules. We can implement models of intelligence to evaluate and understand. We can explore consequences of different algorithms and representations. So that basically, this is 2 different things. And you can say it is engineering. You can use AI to solve engineering problems, make better decisions. We can design better AI with science. Only you know the science, based like the neural AI, the root in neuroscience. So it is a science subject as well. Only when you know better physical world, you can create better AI that can be used in this physical world. Okay? So after we go through the history of AI, now the difference between AI, deep learning, and machine learning. hopefully you can have a better understanding what are the correlation. AI is a big scope, cover everything basically, right? And no matter the search algorithm, no matter the knowledge-based system, logic rules, they are all belongs to AI. No matter the machine learning, deep learning, they are all belongs to AI. And machine learning is a subset of AI that includes statistical techniques that enable machines to improve at the tasks with experience, and they include deep learning. They also include the models like least squares for fitting models that is just fitting models from data, and they don't have the objective of intelligence, but deep learning does, right? So deep learning, it is a subset of machine learning composed of algorithms that permit software to train to perform tasks, and like speech, image recognition, by exposing multi-layer neural networks to vast amounts of data. Okay, they are not the same, but they have this kind of relationships. AI includes machine learning. Machine learning includes deep learning. ChatGPT, large language models, they one type of deep learning models, right? Convolutional neural networks, what we mentioned, it is also one type of deep learning models. Okay, so far so good. So far so good. Okay, so what are key drivers of AI? Two things we have mentioned. Huh? Data, right? Data, big data. The second thing, computing, right? These are two key drivers why AI is so powerful. Okay, that's why only giant company can build ChatGPT. Okay, that's why academia people could not do so. Only this giant company. Okay, one is big data. A few years ago, we always say data is a new oil. Oh no, this is just oil. The new oil is GPU, right? We have data everywhere. So I will just skip these few things. So what is big data? Of course, large volume of data, tremendous volume of data, right? And it is generated very high velocity every day. Internet generate new contents. You post your information in social networks, right? And the track data, this streaming data generate in a very fast way. Velocity, variety, different kind of data structures. For example, text, image, video, table data, different type of data, right? And velocity, this is about uncertainty. Data inconsistency, incompleteness, and ambiguities, deception, model approximation. These are basic characteristics of big data. The GPU is a new oil and gas in these days. Okay, of course, GPU. Even us right now, we barely can buy enough GPU for our PhDs to do their research. It's so expensive, and because of limitations, the politics issue, we could not buy some special type of GPUs. Okay, these are our bottlenecks. All right, so these are basic introduction of AI today. We introduce what is AI from the history of AI, 3 different roots: symbolic AI, neural AI, and statistical AI. And we understand that two key drivers, one is data, the other is compute. That's why AI is so powerful today. Okay? So here, before we get into our tutorials, I have two questions to you. One is, what is the biggest benefit of AI in your mind? The other is, what is the biggest risk of AI in your mind? These are dual technology. The good one, the harmful one. What is the biggest risk? What is biggest benefit? Huh? Great.
I think the biggest benefit of AI would be the access it gives to people to very large information as it is used today. It replaces Google search, and in a lot of people use it in order to have access to easier information. And I think it gives this is the biggest benefit, wider access to information. And the biggest threat for me would be, with this easy access, how is the data that comes out um, of the models, because it can be manipulated uh, for some, even the videos that are generated, or photos, or they can serve um, political views, and so it can be a threat, like manipulation. Fake videos, or videos that serve a certain point of view, that because it's so easy to make them. It takes few seconds, so you just say, okay, this guy talks about this subject to another person, and after you can widespread it on social media, and it doesn't take more energy than that. And yes, you can manipulate the data, or even how the AI acts, like Sam Altman. He says that he can make the AI, like ChatGPT, nicer, or maybe to respond in a certain way. So if you can, I don't know if you realize how much power he has, because he can definitely uh, make changes to the codes of ChatGPT, and it can answer questions in a certain way, or and this can be manipulated. But so yeah.
Yes. Yes. Very good point. The biggest benefit is everybody can accessible more information, right? I think this one can sort of work AI for education. Can we say that? Everybody can learn things, just communicate with ChatGPT. It's very easy to get organized information. And the biggest risk is the more manipulation, information distribution, right? Any other ideas? Benefit, risks.
Uh, I think I don't know have what benefit. Maybe he just said what I think, but I think with another risk of AI widely used is the damage to the creativity industry. Yes, it's so powerful, it's so convenient. Most of the people using it, it will maybe damages not only temporary, maybe forever. Like some of people you just keep using it and make part of the people who have the talent of creating a masterpiece to relying on using AI to not sharpening their talents of it. So we lost maybe a great artist or great uh investment something. I don't know.
Yeah, that's a very good point. And I think this is also a very big problem. What is education in these days in the era of AI? So for us, we're okay because we know what is good for us, what is bad for us. But what about for kids, for children? They don't know. They're just so convenient. They can get any piece of information. Right? So, but of course, we will not avoid the use of ChatGPT, but we should know how to use it wisely. Right? This is one very, very important aspect. Any other ideas? We haven't have any girls. They are so shy. Any? Any ideas? You're so shy in here. No. We're from computer science. Yes. So one aspect, benefit, the other aspect, risk.
I think the biggest benefit probably for the efficiency of life. So it reduced the cost of time consuming for like corals and what we don't usually want to do, those repetitive that like corals, housework. That's it's more likely achievable for AI to solve for us. To improve the efficiency of life. Yeah, and it's kind of more real instead of talking about something fancy but not achievable. And for the biggest risk, if the AI has ability to have a body instead of just a thinking model, it probably could. I think for the highest rate, it could like a murderer, like killing humans, death. Yeah, if it has a body. Because right now, lots of AI, they don't have a physical body. They just have like the neural system, the mind. But as long as one day, if they achieve with like a flexible bodies for them to move as much as they want, aligned to their mind, it's gonna be like probably more, even more like a human. Oh, what is that?
Serious. That is something bad. AI. Fight back human.
Yeah, I play a game. It's called Detroit.
What's the word?
Where's the world?
Yes, that's a series. I think I'm not sure how many series right now. The Where's the world? Let me check for you.
Okay.
It's something bad. And basically they can do anything. They kill people and do something that is not the laws. And someday the AI just like that. They have their thinking.
Do you know where you are? I'm in a dream. That's right, Dolores. You're in a dream. Have you ever questioned the nature of your reality?
Welcome to Westworld. We're going from all our hosts are here for you.
All of them, they are robotics, basically.
You.
Are you real?
Well, if you can't tell, does it matter?
What are your trying to meet my maker?
Terrified. Raphael's faces of me understand me. Like a Belgian has told you something very spoken. I think there may be something wrong with this world. Something higher than anything.
So the basic idea of this series is that they create a robotics world. And as long as you have the money, you can just get into the world and do anything you wish. And there's no law, no ethics there. And this world is just keep happening, the same thing, again and again. And the robotics just be killed and then being alive again and again. And someday the robotics just have their own thoughts and then fight back to human. That's the basic story. That's something risk you're talking about. Okay, and all will be just today's content, and we'll move to the next section, tutorial. Okay, okay, and I just hand over to Hawkeye. Because AI, I mentioned that the publications, and usually you can figure out the solutions, the ideas, even DeepSeek, even the ChatGPT from papers. So for first tutorial, we introduce how to find good papers, how to read papers, these research articles through learning better AI, okay?
Okay, hello everyone. So welcome to today's tutorial. It's our first tutorial. And my name is Hawkeye Hong, and I'm from the Department of DSAI. And you can contact me if you have any questions via this email. And the slides will be uploaded to the Blackboard soon. And I think in the following tutorials, we will upload the slides before the class, and you can review it before. And today we will introduce 4 topics, like how to search a paper, and how to read a paper, and how to write a paper, and finally how to present a paper. And just Professor Lin asked several students, and many of them answer that you want to continue to study for AI rather than go to the company. So if you did interested in academic, you need to really care about these 4 topics: search, read, and write, and present, and in particular for AI papers. The first is how to search a paper. In how to search a paper, we have no how to search things, but in paper it is a little bit different. So in academic life, you need to narrow down your search scope. And in fact, you need to focus on top conferences and journals. So what are good conferences or journals? And in fact, there are no common accepted standards, but you can select based on these indicators. The first is the impact factor, or IF. This is an indicator to measure the quality of the journals. And the second is for conferences, there are no IF or impact factors. So you can refer to the CCF or China Computer Federation, and they have a list, and they will rank the journals and the conferences as CCFA, CCFB, and CCFC. And to be honest, you need to focus on CCFA. They are all top conferences or journals. And the third is, the papers are in the commended list of the Department of Computing, and or the DSAI, or because here we focus on the AI papers, so we will only focus on the recommended list of the Department of Computing or DSAI. And maybe in your department or in other departments, they have other recommended list. And here we will list several examples of the top journals. Here are the several top journals with high impact factors, like transactions on pattern analysis and machine intelligence. This is also known as TPAMI, and transactions on cybernetics, evolutionary computation, and neural network and learning systems, or image processing, knowledge data, and engineering. Maybe you have known some of them, and also you may know more than these journals, like Nature Machine Intelligence or Nature Computational Science. There are some journals following the Nature, and the next is the conferences. In fact, in conferences, there are no impact factors, so you cannot to search the journal conferences based on the impact factors, but you can search by the CCF. And here are the several lists of the CCF conference, top conference, like in the database, data mining, or content retrieval. There are ACM knowledge discovery or data mining, or IEEE ICDE or ICM CMD. And for the artificial intelligence, there are several, like the IEEE CVPR or the ICCV or ICML or AAAI. And you can refer to this link for the details of the recommended papers conferences by the CCF. So beyond this, you refer to the journal and the conferences. You may also refer to the search engine, But to be honest, the pure Google or the pure Baidu or something like that is not that efficient. So we may focus on several particular search engine like DPLP and Google Scholar and actually Explore. And among this, the Google Scholar is most widely used. Like in the Google Scholar, you can input several keywords or the titles or the author's names and search for the papers. And this is a very good search engine for papers. And beyond this, beyond the journals, conferences, and the search engine, you can also refer to some online communities like the Paper Weekly, AI Era, Google AI Blog, or MIT News. And in fact, nowadays in China mainland, there are many others like WeChat, like Red Note. They are also, in fact, there are also some good resources to get to know to the latest updates in the AI research. And also latest research discussion about preprint or published papers. Also, Professor Lin mentioned that in archive nowadays, almost thousands or hundred papers published by day. So it is, you can also refer to the archive or some or things like this to get the most latest papers or the updates in AI community. So next, when we find a paper or find a good paper, so we need to read it. But how to read a paper? Um, it is not that difficult, but there are some rules, like according to the Andrew, uh, he is a very famous AI scientist and AI educator. So you may have know him, and here is a recommended rules from Andrew. The first is when you want to explore a topic like for example, if you are interested in causal learning or AI for science, first you need to compile a paper list. Like if you just need a basic understanding of this research area, you need to collect 5 to 20 papers. And if you want to have a very good understanding in this topic, like even you want to conduct a research in this topic, you need to collect 50 to 100 papers. And after compile a paper list, you need to start to read. And for the first time, and in fact, almost we cannot read a paper only once. If you only read it once, it is not that a good paper. And so if it is indeed a good paper, you need to read it in multiple times. And the first time you read the title, abstract, and pipelines and figures. In this term, in this time, if you can discern whether this is a good paper based on the title, abstract, and pipelines, and you can decide whether you continue to read or not. And in fact, the title, abstract, and the pipelines and the figures are also the key components of a paper. So when in the following in the following sections, we will discuss how to write the paper, and these are also the three key components that you need to care about when you write. In fact, because when you write, you need to think as a reader. When a reader find your paper, what do you want to convey? So when you read a paper, you also need to think as a writer. What does the writer want to convey? What does the writer want to tell to you? The title, abstract, and the pipelines are the key points. And the second time you read the introduction, conclusions, and look at the pipelines and figures again. And in the second time, introduction and conclusion are important. And in fact, the introduction is a summarize of the whole paper from the motivation, from the related works, from the method, from the experiments, and in and finally to the conclusions. So all are summarized in the introduction. So if you can understand the introduction, you can almost understand the whole paper. And also look at the figures and the pipelines again. And in fact, the pipelines of a paper is very important because nowadays many people's researchers will spend a lot of time on refining their figures and pipelines to better illustrate their ideas. Because nowadays there are many papers, like in recent, like a very recent conference, the Triple AI, there are almost 30,000 submissions. So it is amazing. It is too many papers. So researchers want to highlight their papers. They want reviewers, readers to find that their papers are interesting. So they will spend a lot of time on pipelines and figures because we people love read figures rather than the words, right? So the second time you need to concentrate on this, and there are a third time. In the third time, you need to read the whole thing, but skip the math. And in fact, because this is the AI conferences and the AI papers, and if you have read any of the AI papers, you will find that the theoretical or the mathematical part is not that important, or it's well not occupy the whole part of a paper, but it is a little bit difficult for AI researchers. So for the third time, you need to read the whole thing, but skip the math. And the whole thing, what does the whole thing mean? It contains the methodology and the experiments. The experiments is something like the authors develop a method, develop a new model, like a new large language model, and conducted several experiments and show that his or her model is very powerful and something like that. And the method is about how he or she establish the architecture of the model. But in this time, you can skip the math. But after this time, you need to make sure that you did understand the method and the experiments. But so, but you skip the math this time. But if you really find this paper is a good paper, you cannot skip the math. So the fourth time, you need to read the whole thing. This time you need to include the math. I just mentioned the math did not occupy the whole paper in AI papers, but the math is almost the most important, the most basic part of the AI papers, because the mathematical or the theoretical part provides the intuition or the foundation of the model. Nowadays, some people criticize the large language model because it is less explainable, or the foundation behind the large language model is not that solid. So develop the math or theories behind your model is very important. So when you read the paper, you also need to focus on this, how these authors or how these researchers develop their mathematical or theoretical background for their models, for their for account for their architecture. But also in this time, you can skip parts that don't make sense. And this is also important because there are many good papers and there are many papers, just papers, not that good. So you can encounter papers that is very good, but it also can contain some flaws, some errors. So don't think that all papers published are very good or flawless. In fact, researchers are also human, and human make mistakes. So don't believe the paper too much. They also contain some errors, and this is how to read a paper. And when reading, keep in mind for these 4 points. What did the author try to accomplish? And what are the key elements of the approach? And what can you use for your own research? And what other references do you want to follow? And for the first and the second, it is all about to understand this paper. This is important, and this is almost the pure intuition or the motivation to read a paper. But for the third, this is an important thing that you need to think when you read the paper. Because if you want to enter the academic, you need to conduct your own research. So you need to find your research point by yourself and how to find it. So reading a lot of papers and find this, what can you use for your own research? And for the fourth point, it is about the paper. The papers contains several parts, but there is one part that people may ignore, the references. Maybe you read a sentence, A, B, C, D, blah, 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 and a reference behind that. Sometimes you may just skip the reference, but in most time you can follow these references and to explore more on this topic. This is also how you compile your paper list. Like maybe the teacher, professor just send you one paper, a good paper, and but you can, based on this paper, and explore the references list and find more based on this paper. So next to the third part, how to write a paper. This is really important, and if you enter the academic, this is almost the most time you will spend on writing a paper. And so why we write paper? You need to think about this before you start to write. The goal is to infect the mind of your reader with your idea, like a virus. So the greatest ideas are literally worthless if you keep them to yourself. So the original motivation of a paper is to share ideas, to convey people's. So why nowadays we find that paper is very structured, from abstract introduction, related works, method, experiments, conclusion. You can say that it is a stereotype or something like 八股文 in Chinese, but it is the most effective way to convey ideas. People find this is the most effective way because people find once you read the title, you can decide whether to continue and abstract and introduction and the following. This is the most effective structure. But also, if someday you are a genius and you find a new structure that is more effective, like you can state your method first and then experiments. If you convey ideas by this way, you can establish your own paper style. But nowadays, the stereotype like from introduction to conclusion is the most effective way. So we follow this. And the motivation is we want to convey the ideas. We want to persuade others. And the next is so if you have write a paper, you may think this is a general pipeline. You formulate an idea and you do research, conduct some experiments, then you write a paper. So may I ask how many of you have write an academic paper? Okay, quite a few. So do you agree with this pipeline? In fact, this is not a good pipeline because research is struggling. It is a very lucky one, but generally we can know this. So I recommend this way. You formulate an idea, then you just start to write, then do research and repeat. Why this? Because when you formulate an idea, you can start to write the papers by starting the related works. Related works contains the works that have been done. For example, if you want to research on the large language model and you develop a new architecture of the GPT or the transformer, but before you conduct the research or conduct the experiments, you can start to write the related works. You need to explore what people have done, like from the GPT-2 to GPT-3 to GPT-4 and to nowadays GPT-5. You need to explore what people have done. In case that you didn't do the same thing, this is very important because the novelty is very important in research. If you just develop something that have been found, this is almost useless. So it is very recommended to start to write paper, especially the related work part. And after that, maybe you can make sure that your idea is novel. Nobody do this before. So you can do research and conduct some experiments. And during this, you can also continue to refine your papers, like the methodology part, because idea and the final version of your model, there are a huge gap between them. So you can write the paper to help you better have your better organization for your architecture. And this is also important because you need to discuss with your supervisor, like with your collaborators or something, or some people else. So in summarize, I recommend this pipeline because it helps us, it forces us to be clear, focused. And the second, it crystallizes what we don't understand, like what people have done, what people haven't done, and opens the way to dialogue with others, reality check, critique, and collaboration. Because, in fact, if you indeed enter the academic, you will get a supervisor, and in most cases, your supervisor have other students, so you cannot take the code or take the pure results to your supervisor and discuss. So you can write something to help you to discuss with your supervisor. This is more effective. And I just said there is a very typical structure for a good paper, like from the abstract introduction, methodology, and the results or the experiments, and to the discussion and the conclusion. And this is summarized by this book, Science Research Writing. This is a good architecture because it is proved to be effective. And now I will expand the shape, like why the abstract or the introduction or the discussion is shaped like this. Because for the abstract, it need to be short, and you need to convey the core, the most important idea of your paper. And but for the introduction, it is from a quite broad insight of, like if you just develop a computer vision algorithm, it is a very maybe it is a very minor improvement, but from when you write the introduction, you need to stand at a very high point or a high level point, like from the computer vision or something like that, and then slowly narrow down to your research topic, narrow down to the to your motivation, like some people haven't done. So you need to, from a broad vision, to narrow down your research topic, then to the methodology and the results. Methodology is what you did or what you use. It is something, the architecture or the algorithm improvements you have developed. And continue to the results. It is what you found and saw. It is you conduct experiments on several data set or benchmark and collect the results and analyze the performance. And finally, to the discussion. Here, you need to go back to the broad view, like from your minor improvement on this algorithm can bring out something big than this narrow topic. So it is shaped like this. So the next is details for each part. Like first, abstract. Abstract is generally one paragraph summary of the entire study, and it is a summary, but it is short, but it is also a summary and contains almost everything, from the research background to the research problem and the model and the results and the conclusion. But be remembered to be brief, because abstract. To be honest, the papers, the first reader of the papers are reviewers, not us, not the other researchers, but the reviewers. And the first reviewer will read your title, but generally they will not reject based on your title. But the next reviewers will read your abstract, and almost many reviewers will set an expectation on your paper based on your abstract. If your abstract is excellent or interesting, the reviewer will be happy, and they will go in details to your papers. But if your abstract is not that interesting, the reviewer may feel bored and pay less attention to your paper. So abstract is important, but be brief. And the introduction, it is also highly structured, and generally many people follow these patterns, like from the background, introduce what is the research context and what is the state of the art, and then next state the problem, what is missing, what are the drawbacks, and explain the goals and your methods, what are the operation goals of the paper and what are they achieved, and present your results, say your contributions, and finally to the paper overviews, outlines of the rest of the paper. For the paper overview, for the journal papers, they generally contain this part, the paper overview. But for the conferences, some paper do contain this part, but some papers do not contain this part. And for the introduction, and here is a very detailed, like for each sentence, what should you write? Like for the first sentence, for the first and second sentence, establish the importance of this research topic and provide general background information. And you can see on the right hand, it is an example from the first sentence to the last sentence of an introduction, and you can refer to this after the class. And after the introduction, it is the methodology. The motivation of methodology is provide an overview of the method itself. And to be honest, the method you do not need to write in a fancy way or very poetical or even romantic way. You just need to be clear, because the method is important to your readers. you do not want to confuse your readers. So it is accepted to read just like a state in steps by steps, but you need to ensure provide details about what was done and continues to describe what was done in details. So here the details are important in the methodology because the clear is important. And the experiment, and in fact, the experiment, you need to give a general overview of the results and invite the reader to review results and select specific results in detail and compare and mention problem. And if you have read several papers about the especially publishing AI, nowadays AI papers they concentrate on the accuracy. Like your paper improves the accuracy by 1% or 2%. These are good, but these are not enough. A good experiment or a good analysis on the experiment is to explain why your model improves this performance by 2% and why this improvement is achieved. You need to explain the reason behind this phenomena and convey some ideas to the reviewers, to the readers. These are also important. And the conclusion here, the conclusion we need to back from your model, from your results back to the broad impact. Like so, in the conclusion, you need to first state the problem and state your goals and methods, your results, and finally back to the broad impact, like the impact to the society or to the whole community of this topic. And here I also provide some signaling language like how to connect to sentence or how to make sure the transitions between sentences are smooth. And you can refer to this by yourself. And here it is an important part of writing the paper. It is the review, because in most times we write academic papers and we won't get published. So we will submit our papers to the journal or to the conferences, and they will select some reviewers to review your papers. And reviewers will provide some comments, feedbacks to your papers. And based on this feedback, the journal or the conference committee will decide your papers will be accepted or not. So reviewers are very important. And when you get some feedbacks from the reviewers, an honest suggestion is treat every review like gold dust. Be truly grateful for criticism as well as praise. This is really, really hard, but it is really, really, really important. Sometimes some reviewers will just criticize your paper out of nothing, um, but maybe it is not something like over worried, but you may think maybe some part of your paper can still be improved to even let this idiot reviewer can understand your paper. So be patient, and this is really important. So read every criticism as a positive suggestion for something you could explain more clearly. And then do not respond. You stupid person, I mean X. Fix the paper so that X is apparent even to the stupidest reader. And thank them warmly. They have given up their time for you. In fact, this is the third one is important because reviewers are volunteer. They are not paid, so they are volunteer to review your paper. Even they treat your paper very with bad attitude, you still need to thank them because they did spend some time on your paper. And the last is how to present paper. This is if your paper get published on journal. Generally, there are no there is no need to present your paper. But if your paper is published in a conference, you need to attend this conference, and you may need to give an oral talk or a poster presentation there. So it is how to present a paper. In fact, this is also important because in AI conference, like for the ICM, iClear or NIPS, generally the accepted papers, for example, maybe the ICM this year, they accept almost 3,000 papers, but the participants are more than this number. There are almost 30,000 people who even have no published paper will also attend this conference. So present your paper is a good way to convey your idea, convey your paper to others. So it is also important. So how to present paper? Generally, you need to deliver a poster presentation at an international conference, and your goal or your motivation is giving an effective poster presentation. Here are some suggestions, like don't put anything in the poster and don't leave your poster during the poster session. Don't stand in front of your poster and don't read your poster about your audience, but to talk to them. And don't bore your audience with a long walkthrough, no more than 3 minutes. And here are also some do's, like use your poster as a tool for communicating with your audience, and get prepared or stand to the left from the left to the right. And most important is stand by your poster to meet and interact. Generally, if you have attended some AI conference, because some people will get bored and leave their poster there and find some sightseeing. It is not that good because you have paid your time and you have paid some monies, and so you need to stand by your post and deliver your presentation. And here are some effective poster presentation rules you can refer by yourself later. And the last is research with large language model. For searching paper and reading paper, I think nowadays we are accepting this